Oh hey, my name is Amelia Frye and I'm going to be teaching you about all things the atmosphere, high pressure systems, low pressure systems, and a bit about tropical cyclones.
The Earth's atmosphere can be categorized into 5 distinctive layers, all equal in importance. Humans inhabit the troposphere, the bottommost layer. From here, the layers continue into the stratosphere, mesosphere, thermosphere, and finally the exosphere. In between these layers are designated areas called the pauses. In these areas, the temperature remains at a constant. Temperatures in the atmosphere range on average from 15 to 190 degrees.
The chemical composition of our atmosphere consists mainly of nitrogen and oxygen, which equates to approximately 78 and 20% respectively. The remaining 2% includes a variety of trace chemicals including carbon dioxide, nitrous oxide, methane, and ozone. The Earth's weather systems are formed mainly in the troposphere, which extends approximately 12 kilometers from ground level. Weather events that occur in this area are controlled by changes in air pressure. Tropical cyclones are a rapidly revolving storm system characterized by a low-pressure center, which is a closed, low-level atmospheric circulation combined with strong winds and a spiral arrangement of thunderstorms that form to produce substantial rainfall. These tropical cyclones spawn over large bodies of water no cooler than 26.5 degrees Celsius. Once formed, tropical cyclones drift poleward, meaning towards the poles, and westward, meaning towards the west. A tropical cyclone revolves in 4 stages, each fundamental to the formation and production of a cyclonic system. The first stage commences by inflowing air spanning across the surface, acquiring heat via the evaporation of water. This is due to a process called latent heat, in which the heat required to convert a liquid into vapor is performed without a change of temperature. During this evaporation process, the ocean's surface cools and the air inside the system therefore warms. Stage 1 is isothermal, meaning only a change in phase has taken place, however the temperature has remained at a constant. The ocean's surface temperature is very warm, being 26.5 degrees, therefore will evaporate at an increased rate rather than water at, say, room temperature. During the second stage, the warm air previously risen then cools within the eye wall, while conserving the total heat content. This process transforms heat energy into gravitational potential, pushing upwards along the eye wall. The heat which was previously conserved as latent heat is then transformed into sensible heat during condensation. Sensible heat refers to the change in temperature of a gas without a change in phase. The energy is being provided by the water molecules previously evaporated during stage 1. Stage 2 is isentropic. During an isentropic process, temperature, pressure, and volume are all variables. The only constant is the entropy, which will be the same at the end. Entropy is a quantity representing the unavailability of a system's thermal energy due to a degree of disorder. Stage 3 is the air that outflows towards the upper troposphere, pushing into the cold tropopause. Heat is lost during infrared radiation, IR, into space, cooling the temperature of the system. IR light is a form of radiation on the electromagnetic spectrum. Heats that form a part of the electromagnetic spectrum are invisible to the human eye, but can be felt as physical heat. Stage 3 is isothermal, much like stage 1. Finally, during stage 4, the air subsides, meaning the air becomes denser and moves towards the ground, warming at the outer edges of the storm, whilst conserving the total heat content. Much like stage 2, stage 4 is isentropic, meaning the temperature changes, warming once again due to the outside air temperature. From here, the sea then warms once again and the cycle begins right from stage 1. Cyclones relate directly to Boyle's law, which states that at a constant temperature for a fixed mass, the absolute pressure and the volume of a gas are inversely proportional, which can be written as P is inversely proportional to 1 over volume, or P1 V1 equals P2 V2. So for example, say 1973's Cyclone Kerry, With a pressure of 87 kilopascals, measuring approximately 28 kilometers squared in diameter and 0.54 kilometers in elevation. In order to apply Boyle's law, we must first calculate the volume. The formula is 1 over 3 pi r squared h. Subbing in values 1 over 3 at pi 28 squared 0.54. The total value is 443.34 kilometers. Now, Boyle's law does not only relate to a low pressure system, but also directly relates to a high pressure system, where you have dense air subsiding downwards and as a result, at the surface spreading outwards. Boyle's law states that at a constant temperature for a fixed mass, the absolute pressure and the volume of a gas are inversely proportional. Air pressure is directly related to the total weight of molecules that compose our atmosphere. High pressure causes air to flow downwards and converge outward before reaching the ground, preventing clouds from forming, therefore resulting in the clear blue skies that we often see in our area. The maximum high-pressure system recorded was in Tostangal, Mongolia, with a pressure of 108.5 kilopascals, a very big comparison to 87 kilopascals that was measured during Cyclone Kerry. If we assume the same volume as the previous example of our truncated cone was 443.34 kilometers cubed, our equation is, like before, P1V1 equals P2V2. Now sub in our values, P1 being 101.3 kilopascals, standard temperature and pressure, P2 being 108.57, our high pressure system, and V1 being 443.34, the volume of our truncated cone, and V2 being our unknown value, 101.3 times 443.34. We then divide this sum by 108.56 to give our value of V2. V2 equals 413.65 kilometers. As you may have noticed, there is quite a large discrepancy in regards to the calculated V2 volumes. In the low pressure systems, the volume increases to 516.21 kilometers cubed, whereas in the high pressure systems, the volume decreased to 413.65 kilometers. Assuming the temperature has remained at a constant, the kinetic gas law states that if the volume of a gas is reduced, gas molecules will come close to each other, but there is no change in the velocity of a gas molecule. I hope you have learnt plenty about high pressure systems, low pressure systems, our atmosphere, and tropical cyclones.